Assalamualaikum and what's up guys? So today I'll be teaching on how to do the Simulink simulation for the LFC low frequency control system. This is for power system control. So from the question we can see it's a 2-array system connected by tie line with hash following parameters on a 1000 mega per ampere common base. So this is for the area for the initial and for the second one. So this is 2 area for the LFC. And the units are operating in a parallel at a Malaysia nominal frequency, which is 50 Hz. The synchronizing power coefficient is computed initial operation condition is given to PS equal 2 per unit. So for the simulation part, we can see that for the LFC is a control system of here. PRF1 is for the control system for 1, and this is for the 2. 2 system with only primary LFC. At the bottom here, you can see the integral, whereas this is a PID, and the gain is the PS here, 2 per unit. So this is for the gain for the integral here. And up here is for the first area for the LFC, and down here is for the second area for the LFC. So from the parameter, we can see this is 1 over R1, 1 plus TG1S, 1 over 1 plus TT1S. This is for the governor, the turbine, and the rotating mass and load. So for from the parameters here, you can see this is 0.2, 0.5, and this is also 0.2 and 0.5. From that, you can have all of the parameters for the Simulink simulation. So you just need to open up your MATLAB and just type in Simulink, or just press the Simulink app here to go into the Simulink here, this one, and then just fill in the component here, whereas it is in the library browser. So in the library browser here, you can see for this simulation block diagram, there's a gain, transfer function, summation, multiplexer, workspace, and integrator. So for the clock, it's find clock, where it shows the current simulation time. Here clock. Then you find transfer function, you just key in transfer FCN. So the transfer function shows the numerator coefficient and denominator coefficient of the block diagram. So I'll explain later. I just put it in the block diagram first. So there's a lot here. And then there's gain. Just type in gain. Gain is the multiplication wise of in front of the signal. This one. Step. The step function. Define step. Here. Out step. Summation. Sum. Any block diagram is fine. It's the same. It's just differentiate. Just pick add or subtract, because you can just change it here. The sign of the loop. You can just change it here. See the multiplexer MUX. Greater. So integrator is one of the PID, whereas I is the integral. So this is it. and workspace. So the workspace will carry out all of the transfer function that you get from here to your MATLAB, where you can plot the graph and just export it to Excel. So the scope to show your signal. Yeah. Once you have all of your component, you just need to connect it all to make sure and make it become something like this here. This is the simulation board diagram for the LFC. But I've inputted the 1 over R1 is here, the gain 1 over 20. And for the transfer function, you just double tap the transfer function and it shows the numerator coefficient, which is the up 1, and the denominator coefficient is below. So denominator coefficient, it shows the highest order of degree at the left side here, the first one. So because this is 1 plus 0.2 s, so this is 0.2 and 1. You have more higher order degree, like s squared or s cubed, just put more. If I put here, it's become 2s squared plus 0.2s plus 1. This one is 0.2. So just key in all of the parameters inside your transfer function. This is for the governor turbine 1. Okay, 0.5, 1. See here, the transfer function for 2. The error 2, this is 1 plus 0.2s, so 0.2 plus 1. Think here, and just put off it here for simulation. And for the 2 here, as you can see from the question, it shows that it is computed from the initial operating condition and is given to be PS equal to 2 per unit. So the PS 2 per unit is put in the integrator in front. So just put the gain here 2. And the step function, it shows here is 0.2. You just set it, the step time to be 0.2 for PL1. So as you can see here, at the scope, after you run it, it shows the bit to bit. Yeah. It shows the wavelength for the W1 here and W2. This one. The wavelength, the frequency for area 1 and area 2. You can just put legend here to transfer function for 5 and 4. You can label it also here to make sure you get it like this. And then for the workspace, for the out simulator, from as you can see here, shows this is for the clock, the time. This is for PM1, total for PM2, and the total for the integral P12. And to show the workspace, you just open up your MATLAB here, and there will be a workspace here showing your output from the simulation. So what you do is just plot out the graph. And it shows the time, PM1, PM2, and PM12. If you want to put it in one graph, just click all of it in one graph. Yeah, all of it, you can just put it in one graph. You can copy the plot or just export the data to an Excel file. I think that's it from me. I hope you understand and happy learning. Thank you. Assalamualaikum warahmatullahi wabarakatuh.